Hello and welcome to the first in a series of videos all about polynomials. We're going to talk about different properties of polynomials and get into the arithmetic, simple and more complex, of polynomials. I think a good place to start might be though, like what is a polynomial? Well, poly is many and nomials is name, and what we can kind of break that down into is just a combination of different factors. You've seen polynomials before if you have any experience with math, and we'll get you some exposure to some of those polynomials here in a minute. So where do polynomials fit in to the real world? The question math teachers get asked all the time is, when am I ever going to need to know this? Realistically, the answer to that question is that not everybody is going to need to know what it is that you're asking that question about. But I'm recording this video on March 25th of 2020, and right now we are in our homes because we're not allowed to leave because the coronavirus that causes COVID-19 is sweeping across the world. And we've heard the word in our social discourse and public discourse on every news channel. We've heard the words exponential growth over and over and over again. And why this is important is because it is kind of shining a light on how math or mathematical models can predict, or we can use them to project trends into the future. It doesn't take too much imagination to see that if the United States data, which is this dark blue one, if that continues if unabated, if we don't do anything about it, in the coming days, this will just do this. It will follow that growth. You can see here that the Chinese model, the data that we have from China, does a kind of different thing. It has this like S shape. That's actually a different kind of growth, where it started off as an exponential growth and then something else happened. And we have another word for that. It's kind of outside the scope of this video. Full disclosure, exponential functions are not polynomials. Okay, they're not, but it just goes to show that there is relevance to these terms, to these kind of mathematical concepts that we learn. Let's talk about polynomials specifically. These here would be examples of using polynomials to model data and to use them to predict future events. These are all financial models. They are different kinds of financial models based on different sorts of seasonality, and if you're adding or subtracting things. There's a much more relevant, I think, polynomial or example of a polynomial model, and we'll show you that here in a second. And climate change. That's kind of one of the biggest issues of our time is climate change. And this graph here models the global average temperature for the last, 168 years. And you can see it goes up and down, and there's all kinds of seasonality here, and there's like, if you went and really got granular with this data, you could pinpoint certain dates and certain years and make conclusions about why the temperature was hotter in certain years. And but overall, you see that there's an upward trend, and we can, using all sorts of factors, all sorts of information about like carbon content in the atmosphere, or carbon dioxide in the atmosphere, and carbon, we get historic information from like ice cores, and we get data coming in on a regular basis every day. We can use all of those factors to create a polynomial that will predict how hot it will be if we don't do anything about it in 5 or 10 years. And we use that information in all kinds of reports, all kinds of scientific reports. So polynomials are very important. Now, these are much more complex polynomials than the kind that we deal with in like high school curriculum. But nevertheless, the thinking and the reasoning that we go through is the same in both cases. At the end of these videos, just two main goals that we'll have, and they could be boiled down into these. So first of all, if we see a polynomial that looks something like this, and if you look at that and it makes you makes you want to throw up a little bit in your mouth, that's perfectly reasonable. This is a pretty confusing looking thing. But after we go through and analyze what are these different data points and what's going on here, we should be able to write the equation of a polynomial that looks like that. We will also kind of go the other way and say, all right, given a gross looking polynomial that looks like this, can we graph it? And that's not just a matter of going like, okay, magically graph. There's all sorts of information that's kind of hidden within this that fourth degree polynomial right there that is telling, and it lets us kind of break things apart and figure out how we would go about graphing something like that. Okay, so we talked conceptually about polynomials, and maybe we should talk a little bit more with some concrete information, some mathematical information here. So what is a polynomial? Well, the mathematical definition of a polynomial is it's an expression consisting of variables and coefficients that involves only addition, subtraction, and multiplication with non-negative integer exponents. So x squared minus 2zx plus 3y is a polynomial because it fits that description. There is only addition, subtraction, and multiplication going on, and exponents are also multiplication. They're just repeated multiplication in this expression. So that is a polynomial. 3x plus 5 is also a polynomial. 3 times x plus 5. There's no division going on there, and there are no negative integers. Sorry, there are no negative exponents, or also all the exponents are integers. Here's an example of something that's not a polynomial. 2x squared minus 3x to the negative first power plus 1. That x to the negative 1 power, that is a negative integer, so it's not a polynomial. And then here's an example that is also not a polynomial because this x is not an integer. It's a variable. This is actually an example of exponential. This would be an exponential function there. Alright, so we're going to be talking primarily about polynomial functions. So we add the word functions, and all that means is we're going to just say f of x or some other letter of x is equal to a polynomial. So when we add the f of x equals, that's now talking about a polynomial function. And here's an example, like f of x is equal to x squared plus 3x plus 2. That's a polynomial function because we have this f of x. And it is a quadratic, happens to be, because it's a second degree polynomial. The highest degree of all these terms is 2. Here's a little bit more information, how we can kind of shorthand the name of different types of polynomials, or at least we can identify what degree a polynomial is. And this is also one of the most important pieces of information that you can possibly have in a polynomial, is what is the degree of the highest term in that polynomial. So, the highest degree term, I should say. So this would be, we have x cubed, negative 4x, and positive 5. The highest degree of the variable is the third degree. So this is a third degree polynomial, also called a cubic. Okay, if you're given a polynomial and you want to know what degree it is, just look at the largest exponent. That's it. Okay, if you have a negative exponent, that's not a polynomial. If you have a rational number, like a fraction in an exponent, that is also not a polynomial. Alright, to make sure you got it, let's play a game called Name That Polynomial. So I'm going to show you a polynomial, and I want you to tell me, is it a polynomial, and if so, what is the degree? So pause the video really quick, answer that question, and then this is yes, it is a polynomial, and it's a 6th degree polynomial. This 6 is the highest term, so as the highest exponent, so it's a 6th degree polynomial. Alright, name that polynomial. Is this a polynomial? If so, what is the degree? This is not a polynomial because this to the negative first power right here is a negative integer. That makes this whole thing not a polynomial. Okay, is this a polynomial? This one's a little bit tricky because when we see this the square root of x, really another way to write that is x to the 1/2 power. And 1/2 is not an integer. 1/2 is a rational number, and so this is not a polynomial. Alright, this is the last one here, so let's see, is this a polynomial? Yes, this is a polynomial. If you look at this, we see that there are only positive integers as exponents. There's a 3 here, there's a 1 here, and there's a 2 here. And so don't let that square root of 2 and the coefficient of this term confuse you. That is still a legit thing for a polynomial. 3 is the largest number that I circled there. This is a third degree polynomial. So we have talked about polynomials, how to identify them, why they're useful, what they are, and in the next video we will talk about basic arithmetic with polynomials, addition, subtraction, and multiplication.